Hello class, good day to all of you. We'll continue our discussion on the partial derivatives. So this time we are going to solve this problem that I had told you last time in our last video to practice. Okay, so here we are given the function of x and y equal to 2 to the minus x times arctangent of quantity y squared plus 4x. So arctangent or inverse tangent. Okay, so our solution here, by the way, we are asked to find the partial derivative of the given function. So we have here the subscript equal to 1, so it means that we need to find the partial derivative of this function with respect to x. 1 corresponds to x. So partial derivative of the function with respect to x. Here, for number 2, partial derivative of the function with respect to y. So 2 here corresponds to y. Okay, so for our solution, by the way, we'll start with this one, partial derivative of the given function with respect to y. So because this one has a little longer solution, this one is a short one, so better to start with this. Alright, so we're given this function and now differentiating partially with respect to y. So it means that here we are going to treat x as constant. Okay, so for this part we have to consider x as constant. So x equal to constant. So I'll just abbreviate this class. Const means constant. Okay, so if this is constant, x is constant, to 2 to the minus the exponent is constant, so this will be constant. So the whole thing here is just a constant, this one here. So 2 to the constant is also a constant. So therefore, we're just going to differentiate partially this part here. Okay? And then we'll use the formula for the inverse derivative of inverse, no? Derivative of inverse or arctangent. Okay? Arctangent of y squared plus 4x with respect to y. Right? So what is the formula of our derivative of arctangent or inverse tangent? So that is 1 over 1 over, so the formula, no? We have the formula of the derivative of arctangent. Arctangent class is the same as something like this. So tangent, and we have here the -1, right? So derivative of arctangent u, okay, this time with respect to y. So we have here this. Okay, so this is equal to, so the formula is equal to 1 over 1 plus u squared times the derivative of u. Okay, the derivative of u. So since with respect to y, so this is also with respect to y. If this is with respect to x, so this would be with respect to x. So we'll use this formula class. Okay, so our u here is, so from this given, this is our u. Sorry. So the whole thing here, class, is our u. Alright, so this is our u. Okay, so using the formula, we have, so since this is constant, so you just isolate the constant and just take the derivative of this part here. So using the formula, derivative of arctangent u is equal to 1 over 1 plus u squared. So 1 over 1 plus u squared. Our u is y squared plus 4x. Then you square this one, then times the derivative of u with respect to y. So derivative of u, so this is our u with respect to y. Alright? So since we're differentiating the function partially with respect to y, then x here is considered as constant. Okay, so when you differentiate this part here, since with respect to y, so we have to consider x as constant. So 4 times x is a constant, so 4 times constant is a constant, so derivative of constant is equal to 0. So in other words, this is the only part that we need to differentiate partially with respect to y. So derivative of this using the power formula, so this would be equal to 2y. Okay, so that's it. And you can uh, rearrange. You can put this constant here, or you just leave it as is. Okay, so that would be the answer. Next, we are going to solve this. So first we did the partial derivative with respect to y. So this time we are going to solve for the partial derivative of the given function with respect to x. Okay, so in this case, class, since we are going to differentiate the function partially with respect to x, so this time we are going to treat y as constant. Okay, so we have to treat y as constant. So if you look at the given, so we can say that the given function is a product, right? So we have here 2 to the x multiplied by arc tangent of y squared plus 4x. So it is in the form, class, of u, no? U times v, right? And we have, if you can still remember in our previous topics, we have the derivative of u and v with respect to x. So this is equal to, so the formula is u times the derivative of v with respect to x. Okay, so u times the derivative of v with respect to x plus v times the derivative of u. So v times the derivative of u with respect to x. So we are going to follow this formula. Okay, so we are going to follow the product rule. So this is the product rule, class. Okay, so in this case, our u is equal to 2 to the minus x, and our v is equal to this one. So this is our v. So the whole thing here is our v, and this is our u. Okay, so applying the formula, so we have, so take note, class, that this is just the sum, right? So you can either write this first or this one first. In other words, you can uh, rearrange, no? You can write this part first, the second term, and then next the first term. That's why here in our solution we started with this one. So we have v, okay, v. So this is our v. I'll just to avoid confusion. So this is also equivalent to v times the derivative of u with respect to x plus u times the derivative of v with respect to x. Okay, so our solution here follow this one. But anyway, they're just the same. Alright, so this is our v times the derivative of this. Derivative of u. So how will you rewrite this one? So this is the derivative of u with respect to x. Then plus, so plus u, okay, this is u, times the derivative of v. So derivative of v, so this is our v. Alright? So performing this operation here, the rule, derivative of this one, 2 to the minus x. So actually this is just the same as the derivative of 1 over 2 to the positive x, which is when you differentiate it, so it gives us 2 to the minus x times negative ln of 2. Okay, so the logarithmic rule, no? Or the ln, the natural logarithm rule. So you just review them. Then plus 2 to the x, then derivative arc tangent. So we know that derivative arc tangent, that is 1 over 1 plus u squared. So we replace this. The result of this is just 1 over 1 plus, this is our u, okay, u y squared plus 4x, then square, then times the derivative of this. And we know that we're differentiating the given function with respect to x, so y is constant. So if this is constant, so the derivative of constant is equal to 0. So y is a constant, you raise to a power constant, so the whole thing becomes a constant. So derivative of constant, so this will be 0. So this part here, the derivative of this is 0. Then you take the derivative of this, which is equal to 4. Okay, so that's why in our answer here, so this is replaced by 4. Okay, so we can stop up to this one, or if you want to simplify, you can also do it. Alright, so I hope you're able to follow. So I think this one here, I just want you to uh, check your formula, no, for the derivative of, you have 2 to the something that is exponential, where exponent here is variable, is not a constant. So it has to do with logarithmic functions. Okay, so next we're given a function of x and y. So let h of x and y equal to sine y ln of y squared minus xy. And then we're asked to find the partial derivative of the function with respect to x. So 1 here again, it means that we are differentiating partially with respect to x, and partial derivative of the given function with respect to y. So again, 2 here corresponds to y. Alright, so for our solution, we have for the first problem here, if you look at the given class, this is looks like a product, right? We have two factors here, the sine of y and also the ln of the quantity y squared minus x times y. But since we're differentiating it partially with respect to x, so therefore we can treat y as a constant. So we treat y as constant. So if y is constant, so the whole given function could just be like a product of the constant and a function. Okay, because if if y is a constant, sine of a constant, the result is also a constant. So when you differentiate, you just segregate this one and then just take the derivative of this. So therefore, you just copy this part here. So we have sine y, then times the derivative of ln. So what is the formula for the derivative of ln? So we have the derivative of lnu. So derivative of lnu with respect to x, this is u, so if we have this formula, derivative of lnu with respect to x, this is equal to 1 over u times the derivative of u with respect to x. So we are using this formula. Okay, so our u here in our given, so this is our u. So the whole thing here, this is our u. Okay, so that's why we have here, when you take the derivative of ln, so we just take 1 over u. So that's why we have here 1 over u. So this is our u times the derivative of u, meaning the derivative of this. So that is negative y. So why it's negative y? Because this is our u. So derivative of the partial derivative of this u, and we're differentiating with respect to x because 1 corresponds to x. So y is constant. So y is constant. So we'll take only the derivative of this part here. Okay, so when you take the derivative of this with respect to x, so y is constant, so the derivative of x with respect to x equal to 1, then multiplied by y, and this is negative, so that's why we have here negative y. Alright, so that's our first part. Then the second part is the derivative of the function with respect to y. So this time, so x is treated as a constant. So x here is a constant. So if x is a constant, so what will happen? X is constant. Anyway, this is combination of x and y. So the solution here is that we will use the product rule. Okay. So this one and this part here. So we have the form of u v. So derivative of u times v. So again, like in our previous example, so we have to use this formula, that the derivative of u times v. So this is the product rule with respect to x. So this is equal to, you can have video, you can start with video, or you can start with u dv. So v times the derivative of u. Okay, so v times the derivative of u with respect to, so this time with respect to y. Okay, so we have here with respect to y. So we use here with respect to y. Okay, then plus u times the derivative of v with respect to y. Okay, so using this formula, product rule, so we have v. So in this case, we started with v because they are just the same as, this is the same as u times derivative of v with respect to y, then plus v times the derivative of u with respect to y. Alright. Alright, so they can be interchanged. The first and second term can be interchanged. Alright, so copying our u. So in this case, this is our u. Okay. Now for problem number 2, this is our u and this is our v. The whole thing here is our v. So therefore, you just copy u, which is sine y. Alright. Then the derivative of ln. So we'll use this formula. Derivative ln is 1 over u, or 1. This is our u here, so 1 over y squared minus xy. Then times, because ln we still have the derivative u with respect to x, but this time we have with respect to y. Okay, but the same pattern, class, but we just need to change this to with respect to y. Okay, and so do we this. Alright, so since we are differentiating partially with respect to y, so it means that x is constant. So if x is constant, okay, so derivative of constant is 0, so derivative of 2y is simply equal to 2. So that's why you have here, sorry, this one, I'm talking about this, the derivative of this. So sorry class, this is the answer already. So this is what we are going to, this is our derivative of u with respect to y, so we have to consider this as our u. Okay, or this part here. So derivative of this, x is constant, so derivative of the first term with respect to y, that is 2y. Okay, and then derivative of this with respect to y, so derivative of y with respect to y is equal to 1. 1 times x, so we have x, and that is negative because this is negative. Alright, so plus, copy this part here, this is our v. So we have v du with respect to y. So v then times the derivative of u, or u is sine y, so derivative of sine, we know that that is equal to cosine y. Okay, so that's it for the next example. And now let's go to I think this is the last example for this video. Okay, so we're given here the function of three variables, function with three variables. So function of x, y, z is equal to ln of the product of yz divided by tangent of the product of xz. Okay, so we are asked to find here the g1. G1 stands for the partial derivative of the given function with respect to x. Then we also have to find the g2, partial derivative of the function with respect to y, and g3 here is the derivative of the function with respect to z. Okay, so now for the first one, or this is equivalent to, if you use the symbol, that's also okay. They're just the same, or if you use this notation. Okay, now this is what we call the quotient rule. No, we'll use, this is a quotient, no, in the form of quotient. So for this problem, we have to use the quotient rule. So what is quotient rule, class? If you can still remember from our previous discussion, quotient rule. So we have, for the quotient, we have the derivative of u divided by v with respect to x. So this is the same as equal to v times the derivative of u with respect to x minus u times the derivative of v sorry, with respect to x, and divided by v squared. So we are going to follow this formula. Okay, so in this case, in our given, so this is our Again, this is our u. So the whole thing here is our u. And the denominator, so the whole thing here is our v. Okay, so following this formula, so we have partial derivative of z with respect to x is equal to ln y. So why is it becomes like this? So actually class is just like this. Huh? So you start with v, so copy v here, uh, v du. So we have tangent. Anyway, the tangent here class, the numerator will be just divided with another tangent of the denominator. That's why what is left here is something like this. But the solution is something like this. So I will show you the proper solution of this. So this is supposed to be like tangent. So tangent of xz. Okay. And then times the derivative of ln. So we know that the derivative of ln is 1 over u, no, ln u, derivative of ln u. Derivative of, I'll change the color. That's a better color. So the derivative of ln u with respect to x is equal to 1 over u. 1 over u times the derivative of u with respect to x. Okay, so the proper solution here is v du. No? We have the v du from the formula v du x. So v is this one, so you just copy that one, then times the derivative of u, or u is ln, meaning the derivative of ln. Derivative of ln yz. Okay, so derivative of ln yz. So derivative of this with respect to x, then minus u. U is this one, you just copy that one. So that is ln y, ln yz. So these are u times the derivative of v. So derivative of v, our v is this is our v, that is tangent, right? Tangent. So tangent xz. So derivative of tangent xz, and it is also with respect to x. And the whole thing is divided by tangent x times z. So this is our v, and then that is squared, no? This is v squared, so you have to square this. So squaring this one. Okay. Now, as mentioned a while ago, we have here tangent xz. We have also tangent xz here, so that's why when you divide this by this one, so what is left at the numerator? So we have this derivative of ln is 1 over So derivative of ln is 1 over u, where u is yz, right? Yz. Okay, so let's see if it can be. Okay, so this is ln yz. So derivative of ln, no? Derivative of ln is 1 over u, where u is 1 over, our u is yz. So this is 1 over y times z, y times z, then times the derivative of u. So derivative of this with respect to x, what will happen? So derivative of this, no, derivative of u. So the derivative of u, which is uh, uh, so derivative of u, which is yz, and take note, class, that we're differentiating partially with respect to x. So we miss something here. So if we differentiate with respect to x and we have three variables here, so it means that y and z, y and z are held constant. So y and z held constant. So therefore, if you are going to take the derivative of here, derivative of this part here, so y and z product constant, so derivative constant is 0. So it means, class, so the derivative of this part, this part here is equal to 0. Okay, so this part is 0, and then when you multiply this by this one and by this one, so the whole thing in this part here on the left side of the negative sign becomes 0. So this becomes 0 here. Okay, then what is left is the minus, so this one here. So what is left is ln y times z. Then the derivative of tangent. So the derivative of tangent is secant, no? That is equal to secant. So derivative of tangent is secant squared. Secant squared u, where our u is equal to x times z. Then we're differentiating partially with respect to x, so it means z is a constant. So if z is constant, we are just going to differentiate x with respect to x. So the derivative of x with respect to x is equal to 1 times z. So that is why we have here z. Okay. So, and then divided by the tangent. So this would be tangent xz. And then squared. Alright. So the whole thing, after differentiating the whole thing here, so this part here, it becomes 0. Okay, this becomes 0. So this becomes 0. So that's why what is left is negative ln yz secant squared xz times z over tangent squared xz. So that is what you can see here. Alright, so this part here. So because the whole thing on the left part of the negative sign, the whole thing is become 0. So excluding the denominator, that is just this one. Alright, so that is partial derivative of the given function with respect to x. So we are holding y and z equal to constant. Okay, so the answer, class, is this one. So they just multiplied it by -1. Actually, it's the same as you just multiply this by -1, then no need to write -1 here, so that uh, this you see this one multiplied by -1, so this is negative ln(yz). Okay, this is similar to this one, negative ln(yz). Okay, then multiplied by secant squared xz times z, and divided by the whole thing divided by tangent squared xz, which is similar to this one. Alright, so I hope you were able to follow it. Now, okay, I will erase it because so that we can solve for the other problem. Now, this time we need to take the derivative with respect to derivative of the function with respect to y. Okay, so I am erasing it just to save space. Okay, so this time we are differentiating with respect to y. So it means for this part, class, we have to treat x and z as constant. Okay, so treating x and z as constant. So this is constant. So VDU, so same formula, we use this VDU minus UDV over V squared, but this time we have with respect to y, for this part. And you have this answer. So why it becomes like this? So simple, class. We have same, we have tangent, tangent xz, because V, so we have here tangent, so it's something like this, class. So originally it is like something like this. So V du, so we have tangent tangent of xz, and times the derivative of, so I'll just do it directly, class. Derivative of this is because of v du, derivative of this is 1 over yz, then times the derivative of yz, derivative yz with respect to y. So x is constant, z is constant, so therefore this is times z. Okay, then minus v d minus u dv, so we have ln, so ln of yz, ln of yz, and times the derivative of tangent. So derivative of tangent, that is secant, right? So this is secant squared xz. Okay, and then you have to differentiate, no? So we have to differentiate. It is our u, class. Our u is xz. Then after you take the derivative of tangent, which is equal to secant squared, and then derivative of this, but x and z, take note that x and z are constant, so it means that when you take the derivative of xz, that is equal to 0, so it means the whole thing here is times 0. So derivative of xz, which is constant, is equal to 0. So this is 0, then divided by tangent xz squared. So tangent xz squared. So squaring this one, and we know that 0 multiplied by anything, so the whole thing here on the second term becomes 0. So the whole thing here becomes 0. So therefore, what is left is only this part. Alright? So only this part, then you can still simplify this one. You have tangent xz. We also have tangent xc here. Alright, so what is left at the numerator, we have 1 over yz times z. So this is it, right? This part. Then times 1 over, there's still tangent xz left here because this is squared. So you can factor this as tangent xz times tangent xz, and then you'd use the other tangent xz to divide, no? So tangent xz divided by tangent xz here. So there's still one tangent xz left. So that's why we have here 1 over tangent xz times 1 over yz, which is this one, and times z. Okay, so this is just a multiplication of fractions. So that's why when you're going to simplify, so you get this answer. Alright, so I hope this is clear to you, class. And lastly, we have the partial derivative of the given function with respect to z. So in this case, x and y are considered constant. So x and y constant here. Alright, so still we are going to use the quotient rule. So we have this is our v, this is our u. Okay, so this part here is our u, and the numerator is u, and the denominator is our v. Alright, so using the formula, same formula, uh, v. Okay, so then just write the denominator because we have the formula says that the derivative of the quotient of v, u and v with respect to, so this time with respect to z, so this would be v times derivative of u with respect to z, then minus u times the derivative of v with respect to z, and divided by v squared. So that's why you see here, you just do this line and then put immediately the denominator, which is the squared. So take note that tangent xz squared is the same as tangent squared xz. Okay, so that's why we write the denominator as this. Okay, so we have v. So writing the v, which is tangent, then derivative of u. So derivative of u, our u is ln, so that is 1 over, right? But we have to write it to make it step by step. So derivative of ln yz, then minus u, so this is our u, which is this one, times derivative of v. So derivative of v, meaning derivative of, this is our v with respect to z. Okay, then applying the formula for derivative of ln and also derivative of tangent, like the one that we did a while ago. So just copy this one, derivative of ln is 1 over u. So ln u, this is our u here. So 1 over u meaning 1 over z. Okay, 1 over, why is it 1 over z? That is supposed to be there's still y over yz, right? Supposed to be there's still yz here. Then multiplied by the derivative of yz with respect to z. So it means that we just differentiate uh, uh, y, z with respect to z. So derivative of z with respect to z is equal to 1, 1 times y. So we have y here. Okay, so we have y here. We have y. So y here divided by y, or y at the numerator divided by y here. So that's why you have only 1 over z. Alright, so minus ln yz, then the derivative of tangent xz, tangent, derivative of tangent, that is equal to secant squared, right? Secant squared xz, then derivative of xz with respect to z. So derivative of xz with respect to z. So dz, derivative of z with respect to z, is equal to 1, 1 times x equal to x. So that's why we have here x. And then the denominator. Okay? So that's it. No? So that's why you don't need to write y here, because y at the numerator and y at the denominator, so that is just 1 when you divide. Alright? So our final answer would be something like this. Okay, so I hope you have understood the discussions class, the explanations. So again, this is a matter of remembering, no, the formulas, because even if you know how to do the operations, even if you know the differentiation rules, but if you forget the formula, so still the same, you will not be able to reach the correct answer. Okay, so that's all for this part. Thank you very much, and see you again in our future discussion. Perhaps I will still add additional two or three more videos for this topic, partial derivatives. Okay, so thank you class, and bye. Have a nice day to all. God bless.